Hey, also, so far this year we have talked about displaying data, one variable data and bivariate data. And now we're going to talk about how do you gather that data. So that discussion starts first with understanding randomness and running some simulations. So first of all, we need to understand what random means in context of our class in the world we're living here in statistics. And when something's random, you know what the possible outcomes are. Okay, so there's some knowledge of what could happen. The thing that you don't know is in any event which outcome is going to happen. Okay, so we need to understand random in terms of this class and maybe not how you've used it um, in your life, in your social life, or just in your life in general. So I pulled some examples from the book. So if you want to look into the book, you can. If not, you have the reference there um, for which question I did grab. So let's talk about these scenarios and see if they're random. So if they're random, we'll know what the possible outcomes are, but we won't be able to predict what's going to happen in that situation. So a coin flip. So we're at home. It could be me, it could be my wife, it could be my son. Who's going to take out the trash? And so we flip a coin. So we know the possible outcomes, especially when you're flipping a coin. The possible outcomes are heads or tails. And so we're going to use that to decide who takes out the trash. Is it random? Well, yeah, it is. Because when we flip the coin, we don't know whether it's going to turn up heads or tails, but we do know the possibilities. And so that's a random event. If you're to ask a friend to quickly name a professional sports team, the team they name is that random. Well, we do know possibilities. There is a large set of possibilities uh, of names of professional sports teams. But the outcome is probably not random. If you asked me to name a professional sports team, I would probably name a team that I like or that I follow, maybe even one that I don't like in particular. But there's probably not you're not able to randomly generate, as we would in statistics, a sports team name. So that's probably the random that you have existed with in your life. But in terms of statistics, that's not a random event. Names selected out of a hat to decide roommates. Well, we know all the possible outcomes. It's all the people that will be placed in that dorm. But what you don't know is who your roommate will actually be. So you can't predict the outcome before it happens, but you do know all the possibilities, and so that's a random event. And before anybody gives me a hard time, I'll capitalize I and is. So now that we've had a quick discussion on what it means to be random in statistics, let's talk about generating random numbers. Sometimes we like to generate random numbers to assign to specific scenarios, and we can do that two ways. We can use a random numbers table, and so what I have here is some random digits taken from an existing random digits or random numbers table. And what I want to do is randomly generate four random numbers between 1 and 50. Okay, and so a couple little things here is that since 50 is a two-digit number, we need to make 1 a two-digit number by putting a leading 0. So 2 would be 02, 3 would be 03, 4, 04, so on and so forth. We want to have the same number of digits. And so what we'll do is we'll start on a line. So if we have a random number, random integers table, we would just pick a line to start with. And then we start at the beginning. So I see the first two numbers are 4 and 5. They do fall between 1 and 50, so that's our first number. Then I look at the next two, 9 and 2. So 92 doesn't fall between 1 and 50, so we can't use that. Our next two, even though there's a space here, 1 and 0, that gives us 10, so that would be our next two, or that would be our next two-digit number. Then we have 17. Then we have 10 again. So we won't use 10 again since you've already used it. So we'll go to the next two digits, 22. And those are the first four just say unique two-digit numbers between 1 and 50 that we could generate from this random numbers table. We can do the same thing using a calculator. So we click the math button and we'd arrow over to probability. Let's see if I can make this bigger. And then we're going to go down here to this random int. So we want to produce a random integer. If we're going to tell it the bounds, so we want to produce a random integer between 1 and 50. Okay, and then if I close the parentheses, it's going to give me one random integer between 1 and 50, and you can do that until you get 4 unique ones. Or we could tell it, comma, 4, and that'll give us 4 random integers between 1 and 50 at one time. And there we go, 28, 43, 49, and 14. And we can do that as many times as we want, and we'll get sets of 4 random integers between 1 and 50. So here's how we would use that in context. So take a second and read this. This is number 7 from page 277. So in order to randomly assign states to these students in this elementary school to do a poster about, we've assigned a number to each of the states. They just did it in alphabetical order, assigning two-digit numbers 1 to 50. And you can see that the problem we just did was generated from this problem. And so the first student gets the first 2 random numbers, and the second student gets the second 2 random numbers, so on and so forth until all the states have been handed out to the 25 students. And so this is the same line we just used, and so the first 2 random numbers that we generate, 45 and 10, because 92 doesn't fit into our range, the first student would get the states labeled 45 and 10. Now, I don't know off the top of my head the names of those states in alphabetical order. Surely you could figure that out if you really want to. The second student would have gotten our second 2 random numbers, 17 and 22. Remember, we skipped 10 because it was already produced once over here. So student 2 gets the states numbered 17 and 22. You would repeat this process. Of course, we'd have to have more lines of random numbers, or we could use technology. We could math, probability, random integer between 1 and 50, and we would want to produce 2 at a time. And we would assign the next student state 2 and 42. Of course, you'd have to be careful to avoid overlap, so sometimes you'd have to regenerate the numbers. So we're sort of building towards something bigger, and that is running a simulation. So sometimes it's just not either financially responsible or practical in terms of getting things done in a short amount of time. It's not practical always to collect data, like actual data from by surveying or doing experiments. So we can model those situations using simulations. And one way to do that is with random numbers. So take a minute and read this scenario, and we're going to model this with a simulation using random numbers to determine who would win the election. So let's talk about the structure of our simulation. We assume there's going to be 100 students who vote, and so to decide which way they vote, we're going to have to generate a random number for each voter. And so one vote is what we would call a component of the simulation, that one random number that we'd have to generate to represent one voter. The outcome of that would be if the vote was for our candidate or the underdog. And one whole trial is an entire simulation where we're simulating 100 voters voting, um, where we have a 55% chance of our candidate being voted for and a 45% chance of the underdog. And then the response variable for this trial would be whether or not our candidate or the underdog wins. So one trial is 100 votes, and the response would be, from those 100 votes, did we get more votes for our candidate or for the underdog? So the way we simulate this using random numbers is we have to assign numbers to each possible outcome. So either the person votes for our candidate or the person votes for the underdog. So since we have a 55% chance of the person voting for our candidate, we are going to take 55 numbers and assign them to represent somebody voting for our candidate. So in this case, 0 to 54. Even though that says 54, that's still 55 possibilities. And so 55 to 99, 45 possibilities, is going to represent somebody voting for our underdog. So we're going to generate random numbers, and every time a number 0 to 54 shows up, we'll log that as a vote for our candidate. Anytime 55 to 99 shows up, we'll log that as a vote for the underdog. We'll want to generate 100 random numbers. Then we'll determine who got more votes. So we can do that using our technology. So I'm going to generate random numbers between 0 and 99. And I'm going to generate 10 at a time. Let's see here. I'm going to make this so you can see my calculator and what I'm writing down, and of course Owen and his pumpkin. So we have a 61. So that's, sorry. All right, I figured out what I want to do. So we have a 61, that's an underdog vote. We have a 20, that's our candidate vote. A 98, a 72, a 30, a 24, a 94, a 92, a 4, and an 11. Okay, so far 5 votes for our candidate, 5 votes for the underdog. So I'm going to repeat that process for you, and then we'll see who won. Okay, so I've completed 100 repetitions of the component. That means 100 people voted, and you can see that our candidate got 10, 20, 30, 40, 53 of the 100 votes. So it was really close, but they won. And so that would be one trial doing 100 random numbers representing 100 votes. And so we probably would want to do more than one trial. We won't do that right now. That would be really time consuming. But over the long run, we could see what happens or how many times our candidate would win versus how many times the underdog would win. And that's a lot easier than getting 100 people to vote and then getting another 100 people to vote and another 100 people to vote. It's much easier to just simulate that using this random numbers. So I'm gonna actually skip over this one so that we can talk about it in class. But I want you to stay with me. I'm gonna pop a few questions up here for you to answer. So make sure you watch this video all the way to the very end, to the very last second, and answer the questions. If you have questions for me, make sure that you write them down or you ask them as soon as you can.